5G is going to be huge. It's going to be amazing to have so many IoT devices all connected in real time, right? Okay, sure. 5G is going to be revolutionary, but not just in the world of the Internet of Things. 5G is going to bring a lot more to the table than just billions of IoT connected whatsamabobs. It's going to completely transform critical communication. It's going to change the future of wireless broadband. It's finally going to make streaming chalk talks while you sit back in your autonomous car on the way to work a reality. I mean, how exciting is that? Okay, maybe you've got other plans for your way to work, but in order to keep pace with the speed, bandwidth, and latency issues that surround 5G, we're going to need to take a closer look at each part of the 5G design process, especially those antennas. Hi, I'm Amelia Dalton, host of Chalk Talk. Today, Owen Barthelmes and Kelly Freeman from Amphenol RF are joining me to discuss the future of 5G antenna technology, why board-to-board solutions in this space are going to be more important than ever before, and why Amphenol RF's HD-EFI connector solution is perfect for 5G network infrastructure. And before we get started, don't forget to click that link. There you can find even more information about RF interconnect solutions for 5G wireless applications from Amphenol RF. Hi, Kelly. Thank you so much for joining me.
Thanks, it's good to be speaking with you.
And hi, Owen. Thank you for joining me.
Hello, it's great to be here.
Okay, Kelly, can we start things off with an overview of 5G?
Yeah, sure. So 5G broadly refers to a next generation of mobile network standards. So we're used to seeing 4G. Now the market is going to move on to 5G. So these new technologies are going to enable high bandwidth and high speed data transfer, low latency. They're also going to vastly increase capacity and coverage. And a lot of different technologies will go into this next generation of standards, including new antenna designs, new network architectures, and use of much higher frequencies and smaller cells.
What do you think are the key markets we're going to be seeing with 5G?
There are really three key markets that are going to heavily benefit from 5G. So the first being wireless broadband, getting internet connectivity both to fixed premises and mobile devices. So an exciting application for this will be 4K video streaming to a mobile device that's 4 times the resolution that we see with HD. Also, critical communications. These are the applications where low latency is going to be absolutely critical, so low lag in data transfer. These can now apply to mission-critical applications that have never really relied on wireless technology before. Great example is autonomous vehicles. And last, massive IoT. So IoT refers to devices that are connected to the internet. These with 5G can be enabled at very high volumes for large-scale insights and control. Great application being environmental monitoring across a really wide area.
So what is 5G giving us that's better than what we already have?
Well, speeds for 5G are estimated to be between 10 times and 100 times the speed of what we're experiencing with 4G. New frequency spectrums will also be opened to allow for much higher bandwidth, and importantly, consistent service in a single global network. So for each of the three key applications and markets that I touched on for 5G, some examples of how these technologies will enable that leap in speed and bandwidth are for mobile devices. Currently, we have internet browsing. You're probably aware of the speeds that we have with 4G from your daily experience. In HD video streaming, with 5G, that browsing will be extremely fast, and 4K video streaming will be allowed, which is 4 times the resolution of HD, and cool applications like virtual reality as well. So this could enable you to have a headset playing a live game or another live experience at that high resolution and low lag in real time. For critical communications, 4G has long informed decision-making by transmitting important data, applications like diagnostics and fault detection. 5G will enable automation of equipment themselves. So imagine you're in a manufacturing plant and a robot is performing a task. That task can now be fully automated through 5G rather than a hierarchical wired system. Similarly, autonomous vehicles require wireless navigation and data communication at extremely high speeds. 5G is predicted to be critical for that wireless communication. In the Internet of Things, Currently, IoT enables data collection on a wide scale, but with 5G, that will be an extremely wide scale, so massive data collection globally. And a key thing to point out with 5G with those applications is that one network globally means that wireless data will be essentially seamless rather than connecting wireless local networks, Wi-Fi, cellular all together. 5G is a single network that will eliminate many of the issues of connecting those disparate wireless systems.
So who stands to benefit the most from 5G?
So obviously consumers, especially with those mobile devices, but also an extremely wide range of other users, enterprises, IoT operators, telecom manufacturers for that smart factory capability, automotive with autonomous vehicles, medical patient data, governments that are monitoring cities and other areas, and many, many more.
Can you give me some specific examples of devices that will incorporate 5G technology?
Absolutely. We touched on handsets, so like cell phones that are using 5G, hotspots, modems, and routers as well, which are going to provide internet connectivity in various environments. Any kind of internet connected device could benefit from 5G, and specifically autonomous vehicles and industrial machines are going to be enabled by wireless technology for the first time. And it's important to note that these devices themselves must have hardware that enable 5G, so typically we'll see a modem, a 5G processing chip, and antennas that support 5G.
So what kind of timeline are we really looking at when it comes to 5G adoption?
We've already seen some limited rollout of 5G, so fixed wireless, that's broadband to the home and office through 5G, have been rolled out in some areas. This year, we've seen some release of 5G-enabled phones. Those are really going to be supported in the next few years when 5G networks are widely distributed. Next year, we anticipate to see perhaps between 25 to 50 operators that are providing a partial 5G network service. And then the next following year, 2021 and beyond, we'll see a global network rollout of 5G.
Owen, we've been talking about new network architectures and antenna technologies, but can you be more specific?
The interesting thing about 5G is it's really going to be an overlay technology over 4G. 4G isn't actually going away. 5G will just be added on top of that. And 5G itself can be broken down into two main areas. For wide-scale distribution of signals to people and devices, there is the low and mid-band macro base station technology. That is primarily signals from DC up to 6 gigahertz, and it's used for transmitting over wide areas, very similar to existing base stations today. So the way this is enabled for 5G is, first of all, there's some new bands opening up. This allows a lot more data to be transmitted through bands that did not exist for transmission earlier than today. This is the 3100 to 4990 megahertz range, so there's a lot more frequency available. There's also new technology being deployed called massive MIMO antennas. And what makes these different is they have active beamforming technology to give them much higher capacity with much lower power usage. All of these devices have a need for a lot more RF interconnect at much higher quantities. The other area is high band millimeter wave small cells. So these are another technology that will overlay over the existing 4G and 5G systems and the macro base stations and allow for, in a very small area, much higher and really extreme bandwidth for specialized applications. So these operate in a very new frequency range of 24 to 86 gigahertz, depending on the exact technology or application. Again, what these will allow is for very specific high-speed connections point to point. But one of the limitations of these millimeter wave small cells is at these high frequencies, the signal becomes very much line of sight. So the device being transmitted to needs to be in visual contact with the antenna. This is going to drive a lot of need for high-frequency test capability, both on the equipment side and on the interconnect side. So there's various products that we've developed that will be in support of these high-frequency test needs.
So what specifically does Amphenol RF bring to the table here?
Yeah, we have a very specific strategy. One of the keys is to offer a diverse range of products with any new technology, we see that many new products will come out and be available on the market. And we have a very specific strategy to not support only one. We support all the industry standards out there so we can be a one-stop shop and have all the products available for our customers. We also are leading with innovative and robust solutions that are scalable, and that's really key because with these next generation systems, what we're seeing is a 10 or 100 time multiplier in terms of volumes of each of those products. So we are developing new innovative solutions that can support those very high projected production volumes. We also have developed a global team that provides specialized local technical support at the global level. And we have development teams that are located in the USA, China, and India. We pioneer open source initiatives. So what we do is as these new technologies, new interface technologies come out, we participate in various industry committee boards that standardize on these technologies and develop industry standard specifications to allow interoperability. We also have the ability to leverage the vast extended portfolios across the Amphenol family, not only with RF technology, but every other interconnect technology that Amphenol offers, including high speed, high power, whatever the need may be. And finally, we can utilize our distribution network to ensure that standard solutions are in stock and readily available.
You mentioned massive MIMO before. Can you explain that a bit more?
Yeah, one of the advantages of the vast Amphenol portfolio is that we have a lot of different capabilities, including a division that focuses on antenna production, antenna design, and massive MIMO beamforming technology. So what a massive MIMO antenna is a fully integrated antenna with the radio integrated directly into the enclosure. And compared to a historical passive antenna that would broadcast broadly, the active beamforming technology can actually steer the signal that's being transmitted or received and offering a much lower power consumption while taking that signal and focusing it down to the users or devices that need the high-speed data. What this does, having this partnership within Amphenol, is allows us to co-develop the interconnect needed to make this function. Where a past antenna would have 4 or 8 connections, these new beamforming antennas have 128 RF connections between the antenna and the radio. So again, the scalability and the multiplier is huge.
So what products do you guys have that support 5G applications?
So one of the key areas is the I/O or input-output connector that would go on a radio or an antenna. As we see on a lot of these products, there's going to be a need for more interconnect on each of those devices. So the existing legacy technologies such as 716 and 4.310 are actually too large for the smaller radios with more interconnect count. So one key product that we have released to the market is the 2.25 series. And this is essentially a size-reduced version of the 4.310 that has been very popular for the past couple of years. And what this does is allows for high-speed, high-power transmission of RF in a much smaller package size. While talking about the input-output category, we have another product that we have released, the Next 10 series. And this goes back to the point of Amphenol offering multiple technologies to support multiple customers across the entire market. So whatever the preference is, Amphenol has a solution. And Next 10 is an excellent solution for the I/O interconnect on radios and antennas, and again allows a much higher density while still meeting the power and frequency requirements of current and next-gen systems.
So we talked about I/O solutions, but what about interconnects within radios and antennas?
Yeah, we have a wide array of new technologies, and this is really where a lot of innovation has been happening with the next generation massive MIMO antennas and the radios that support that. There is a need for new interconnect and for scalability to much higher volumes because of the number of ports per device. So one key area is board-to-board within these radios and antennas, and we have various technologies which fit that well. For very small packaging solutions where we have very small distances between the boards, we have solutions like our pin matrix technology. We also have pogo pin solutions that will allow us to package these and get signals, RF signals, from one board to another in less than 8 millimeters of spacing. When there's more spacing, and especially when the connectors are spread out across the radio or antenna and they're not joined together, HD-EFI is an ideal product. And this fills the traditional board-to-board interconnect where we have a board connector on each side of the board, and we have a floating bullet component which adapts to different lengths between that printed circuit board. And this fits really well in the spacing above 8 millimeters. We also see some needs for multi-port interconnect, when we can take these multiple ports and integrate them together into one housing. We can have even better efficiencies of manufacturing and packaging size. So our AFI Dart product line is an ideal fit for those applications.
HD-EFI seems like it would fit well in the next generation of antennas. Can we talk a little bit more about that?
Sure. HD-EFI expands on a long legacy of products that we have, such as SMP and other products where it is traditional board-to-board single port. And some of the benefits that this product has are the way it's actually manufactured. Traditional RF products are machined, and one drawback to that is cost and scalability for production. So when we developed this product, we really focused on using next generation manufacturing techniques. So the product itself is completely stamped and formed and injection molded. What this does is give us great production scalability. We've also implemented some robustness features into this product from lessons learned of producing board-to-board connectors for decades. This has allowed us to develop a very robust bullet, which provides mechanical robustness as well as a wide electrical bandwidth with excellent performance from DC to 6 gigahertz. So as we look at the HD-EFI technology, there are some key benefits that allow it to be robust and fit well into these applications. One is the closed entry contact. We have a very unique design where the dielectric of the interconnect protrudes forward of the interface itself and provides a protective shield so that when the bullet mates with the printed circuit board connector, it's guided in and the delicate electrical contact components are protected from damage. This makes it a very robust solution. The bullet itself is also symmetrical, so it can be assembled from either side, easing the assembly steps in the factory. There's also some key robustness features, such as a secondary body sleeve, which wraps around the bullet and increases its strength while also improving its RF shielding capability.
HD-EFI can be widely used across 5G, but what about other applications?
Yeah, the interesting thing about 5G is it does touch so many other applications and markets. One of those is automotive, and we see that there's a new technology in automotive called smart antenna, and HD-EFI is also an ideal fit for that 5G application. With smart antennas, the electronic module is integrated directly near the actual antenna that's on the vehicle. So there's a need to pass from the antenna on the vehicle to this electronic module multiple RF signals. They include 5G, but also V2X communication, GPS communication, various other wireless signals. So we see a need for anywhere from 4 to 8 interconnect lines between the antenna and the control unit. And HD-EFI provides an ideal solution for that to communicate from the board inside the antenna to a printed circuit board inside the control module.
Kelly, let's stay on connected cars because that's super cool. Can you tell me more about 5G in connected cars?
Sure. So connected cars, just to provide a brief definition, refers to connection of cars to external devices and the internet. So there's a really broad range of applications that are enabled by connected car technology. Autonomous vehicles is a key next-generation application within connected cars. Similarly, advanced driver assistance systems, both of which are using wireless technology that our smart antennas will be enabled by, and entertainment and mobile internet for drivers as well. V2X, or vehicle-to-everything communication, is really going to be key in most of these applications. So V2X refers to both vehicle-to-vehicle communication and vehicle-to-infrastructure two-way communication, both using real-time wireless data transfer that are enabled by these smart antenna products, particularly the HD-EFI line. So that real-time wireless data transfer can enable things like communicating speed, distance, acceleration, and other factors. These allow a great increase in safety as well as the autonomous navigation itself, and can communicate things like traffic information to a driver and provide that internet connection for a driver. The RF interconnect that supports all of these connected car functions must be very high speed to enable the high bandwidth and low latency data transfer that goes along with 5G.
So how can I get my hands on these HD-EFI products?
Well, Mouser offers a lot of our standard products for HD-EFI. On Mouser.com, you can find PCB mount HD-EFI jacks, which are available through-hole, surface mount, and edge mount, all of which have limited detent and smooth bore options for different disengagement forces per your application. We also have our bullet adapters in 3 different lengths to accommodate various PCB spacings, as Owen described. On Mouser, we have 11.46 millimeter spacing to 16.76 millimeters. We also offer an HD-EFI development kit. So this is a comprehensive kit that serves as an introduction to customers for our HD-EFI series. This kit includes 6 different PCB connectors, 3 bullet adapters, as well as 2 SMA to HD-EFI adapters, and a downloadable zip file with various resources including PDF drawings, step files, and 3D component models. And some of these resources, along with part numbers, are available at amphenolrf.com at the link on this slide.
So now that we covered HD-EFI and I/O, what else do you guys have for me?
So in addition to our 2.25, Next 10, and HD-EFI series, we also offer a lot of different and more traditional RF connectors for wireless infrastructure and 5G. So those include 4.310, 716, N-type, SMA, and our other board-to-board series, SMP and SMPM. We also offer fixed-length cable assemblies and precision test cables. As Owen mentioned, 5G products are going to require precision testing, including high-frequency interconnect. And then high-performance adapters. So we have adapters that are between series, in series, and 3-way T adapters as well.
Okay, let's recap some of your main points.
Yeah, 5G has a lot of new technologies, antenna designs, network architectures, all of which enable more data to be transferred at higher speeds, reliable connectivity over a global network, which offers increased capacity and coverage. So all of this technology will transform both how consumers interact with the world and how enterprises and industries operate. We offer a lot of standard and innovative new products for 5G network infrastructure, including our 2.25, Next 10, HD-EFI, AFI DART, and PIN matrix products, and more traditional wireless products like our N-types, 4.310, and 716s. All of these products enable high density, low cost, and robustness to enable the wireless evolution to 5G.
Excellent. Well, I think that's all I have time for today. Thank you so much for joining me, Kelly and Owen.
Thank you. It was great to be here.
Thank you.
And before we go, you didn't forget to click that link, did you? There you can find even more information about RF interconnect solutions for 5G wireless applications from Amphenol RF. For Chalk Talks, I'm Amelia Dalton from EE Journal. For more Chalk Talks, check out the Chalk Talk section of EE Journal. You can't miss it, it's right across the top. Or head on over to www.youtube.com/EE Journal.